Hello everyone and welcome back to another video. In this video I'm going to talk about different flight modes that are normally used in Radiolink Pixhawk. Well, the Radiolink Pixhawk comes with a number of flight modes, but we normally use only a few of them, and I'm going to talk about the most common types of the flight modes which are normally used. So first of all, we have the stabilize mode. So in the stabilize mode, you have to control the entire drone completely following manual commands. For example, if you want to control the altitude as well the position of the drone, then you have to do it completely following manual commands using your radio transmitter. So the throttle, the pitch and the roll of the drone has to be controlled manually using the radio transmitter. There is no automation in the stabilize mode. But for those who are beginners, it is not advised to fly the drone in the stabilize mode, as you have to control it completely with manual commands. Then we have the altitude hold mode. So in the altitude hold mode, the drone will maintain its altitude automatically as the throttle stick is left to its main position, but you have to control the position of the drone manually using the radio transmitter. So what I want to say, well, in altitude hold mode, as after arming the drone, if the throttle is at 50%, then it's called the equilibrium state, it's called the reference state. If you are deflecting the throttle above 50%, then the the drone will start climbing gradually on basis of the deflection from the mean position, which is from 50% position. So in the altitude hold mode, as the throttle stick is deflected more than 50%, then the vehicle will take off. As we keep the throttle more than 50%, then it will keep climbing, and the maximum climbing rate is most probably 2.5 meters per second, which can be changed from the mission controller. And as you leave the throttle stick to its main position, which is to 50%, and the throttle stick will automatically return to its main position, to the 50% or the halfway state, if the self-centering mode is enabled. In my case, the self-centering mode is enabled, so as I release my throttle, it automatically comes back to its main position, which is 50% position, or it's halfway. So as I leave it to its halfway position, then the drone will maintain its altitude at that point. So for example, currently the altitude of the drone is 10 meters, and as I leave the throttle to 50% in the altitude hold mode, the drone will maintain its altitude. The drone will sustain its altitude of 10 meters, as I've said. But you have to control the position of the drone manually using the roll and the pitch commands. Then we have the loiter mode. So in the loiter mode, both the altitude and the position can be sustained automatically, but you have to take off the vehicle manually, as well change its position manually. So what I want to say, so as usual, like the altitude hold mode, in the loiter mode, as you deflect the throttle stick more than 50%, then the vehicle will start climbing, and as you release your throttle, then it will sustain its altitude. And with the altitude, it will also sustain its position. And if you change its altitude or change its position, then when you leave the throttle stick or the roll stick, then the drone will be maintaining its current position, the position that it will have at that instant of time. So the drone will hold both of its position as well its altitude in the loiter mode. It is also known as the position lock mode or the position hold mode. So there are a number of parameters that you can change. For example, the speed that the drone will be traveling at, and few more. I'm going to show you the parameters in Mission Planner shortly. Then we have the RTL or the return to launch mode. Well, one more important thing to be noted is that if you want to fly the vehicle in loiter, RTL, auto or guided mode, then it's very important that you have a good GPS connectivity. So before flying the vehicle in the loiter mode or the RTL mode, make sure that you check the set counts and the horizontal precision or the edge of value. In that case, it will result in precise positional accuracy, I would say. So then we have the RTL or the return to launch mode, where if the mode is triggered, if the mode is initiated, if the RTL mode is initiated, then the drone will return to its launch position automatically. But as I've already told you, that it's very important to ensure that you have a good GPS connectivity before initiating the RTL or the return to launch. And it is mostly seen that the vehicle returns within a precision of 50% to its launch position. But for that, as I've already told you, that it's very important to have a good GPS connectivity. It's very important that you are flying the drone in clear skies condition and there is no boundaries or hindrances neighboring the regions for having good GPS connectivity. So it's a very good feature, you know. If for any reason the drone goes beyond your vision, beyond your visual contact, then you can trigger the RTL mode and the drone will be returning to its launch position automatically. There are some parameters that you need to manipulate, that you can manipulate it, in the RTL mode in Mission Planner. I'm going to show them towards the end. Then we have the land mode. So in the land mode, the drone will start descending. In other words, it will start landing at the point where the mode has been triggered. So it doesn't require any GPS, but it will start rather it will start descending from where the mode is initiated. So that's all about the land mode. And then we have the autonomous mode or the auto mode. So in the auto mode, the drone will follow a flight plan which is already programmed onto Mission Planner, and it will maintain its trajectory followed by the flight plan. So in that case, you don't need to do anything using your radio transmitter. Rather, if the drone is connected with your computer or with Mission Planner using any radio telemetry, using Wi-Fi telemetry, then you can easily upload the flight plan and arm the vehicle and start the mission from Mission Planner using the Wi-Fi telemetry. So you don't need to use the you have no use of the radio transmitter in case of the autonomous mode. But it is very important again to ensure that you have good GPS connectivity while flying the vehicle in the autonomous mode. Then we have the guided mode, but the vehicle will be flying to a given waypoint. You can change the waypoints, you can change the altitudes where the drone is to fly. And as usual, there are some parameters like the waypoint navigation speed that you may change for reducing the consumption of the battery in these two modes, in the autonomous mode and in the guided mode. So as I've told you, that in the guided mode, the drone will fly to a given waypoint by the controller, and the waypoint is normally given to Mission Planner, and at that time it's very important that the Mission Planner in your computer or on your cell phone is connected properly with the drone, with Pixhawk, with Radio Link's Pixhawk, using the Wi-Fi telemetry. So having a good telemetry is one of the prerequisites for flying the vehicle in the autonomous mode or in the guided mode. Then we have the Geofence. It's not a flight mode, rather it's a feature. So the Geofence might be of two types. One is the Geofence of inclusion and the other is the Geofence of exclusion. So in case of the Geofence of inclusion, the drone will be flying within the fence boundaries and it will not go beyond the phase boundaries. And in case of the Geofence of exclusion, the drone will fly everywhere except the fence of exclusion, except the region that you have drawn as exclusion. So right now I'm going to show you a few of the things, regarding the autonomous and guided and Geofence. So I'm going to Mission Planner and my vehicle is connected with Mission Planner using Wi-Fi telemetry. So first of all, I'm going to talk about the Geofence. So as you can see, I have a Geofence right over here. So to design a Geofence, you have to go to Plan, and then normally it's Mission. From Mission you have to go to Fence, and from Fence you have to you can draw a polygon over here, So if you want, you can clear it from here, and if you want, you can also draw one. So let me see. No, it won't get cleared because it's already saved here, so not a big deal. So you can draw a polygon. For example, the blue one, as you can see, it's already drawn. So let me try to draw a new one. So you can draw a polygon like this, like the red one, for example. So this is a polygon. You can use it either as a fence of inclusion or as a fence of exclusion. So if you use it as a fence of inclusion, then the drone will be flying within the boundaries, within this inclusion region. And in case of the fence of exclusion, the drone will be flying everywhere other than the fence of exclusion. And to set the red zone as the fence of inclusion or the fence of exclusion, you have to click here. If you click fence of inclusion, then it will be set likewise, and if you click on fence of exclusion, then it will be set likewise. But I'm not going to set it right now because I've already set one. So I'm going to clear the polygon, and after that, if you want to, then you can also save the polygon. In order to do so, you have to click on save polygon, and later on you can also load the polygon that I have done myself. So in my case, maybe it's in the desktop folder, maybe yes, over here, poly 6, poly 3. There are plenty of polygons, as you can see here. I've tested them a number of times. So that's all about the geofence, and now I'm going to show you on how you can enable the geofence feature. So you have to go to configuration. Right, it's not loading. Yeah, it's loaded. You have to go to geofence. You have to click on enable here, and as the geofence is pressed, I mean geofence is crossed or touched, the RTL mode will be initiated, or the land mode. If the GPS is not available, then the land mode will be initiated. The maximum altitude will be 15 meters. That means your vehicle will not climb up more than 15 meters. If you're doing so, then the RTL mode will be initiated. And the maximum radius is 300 meters. And as the RTL mode will be initiated, if it is triggered, then it will be maintaining an altitude of 7 meters. You can also enable it from the full parameter list. So you have to click on search for fence, and as you can see, fence enable, you have to ensure that this is 1. By default it is 0, and you have to set the fence action, which is already set to RTL or land. And after that, of course, make sure that you are clicking on right parameters. So that's all about the configuration of the geofence. Then I'm going to talk about the configuration of the autonomous mode. So make sure that you're changing the map to mission. I have already made some of the flight plans, and if you want, you can make the flight plans yourself. For example, click here, click here, click here, click here, and you can see that there are the waypoints which has been loaded below. So the first waypoint will be takeoff for sure. Yes, takeoff, and the altitude, takeoff altitude, say 10 meters. Say I'll be conducting the entire mission at 10 meters altitude. And from the last waypoint, I'll be returning to launch. So let me click on RTL. It's completely dependent on your own wish, on how you are doing the flight plan. I'm doing a basic flight plan right now, and in the later videos, I'll show you on how you can do advanced mission planning. So from here, the RTL mode will be initiated. So right now, you can save the file if you want, so that you can load it later on. Or if you simply click on write, then the mission will be written to the program. So right now I have no interest to load it to my flight controller, so I'm canceling it. Rather, let me load one of the previous flight plans, and the one that I'm going to show you the demonstration. So the flight plan is NFS 3 waypoints, this one. So this is the flight plan that I've made, and I'll show you the demonstration of this flight plan. And I conducted the entire mission at an altitude of 5 meters. The first waypoint is takeoff, and the last waypoint is RTL. So as you can see, from waypoint 1 to waypoint 2, 3, 4, then 5, 6, 7, 8, 9. This is the last waypoint from where the RTL or the return to launch mode has been initiated. I'll be showing the demonstration of this flight plan very shortly in one of the later videos. So in the autonomous mode, there is an important thing that you may want to fix, which is the speed. The default speed is a bit much that the vehicle maintains. It's called the waypoint navigation speed. So let me try to find it out. Waypoint navigation speed. Waypoint navigation. As you can see, WP nav speed, acceleration. There are many things here. You see right over here. The waypoint navigation speed, by default it was 1000 centimeter per second, but I've set it to 800 centimeter per second. And if you want to, then you can of course change the waypoint radius. In that case, the bank angle will be lower if the radius is greater. The waypoint acceleration, you see, if you want you can change them. It was by default 250. I changed it to 200. So these are few of the settings that you have to change, that you may change, you know, if you're flying the vehicle in the autonomous mode or in the guided mode. And make sure that after making the changes you are clicking on write parameters. So I'm not going to write them as I've already written them for one time. And finally, if you are flying the vehicle in the guided mode, you simply have to have to click on where you want to fly. So I will be showing the live demonstration on how to fly in the guided mode, you know, from these dashboards. You have to go to action and then click the guided mode. No, it doesn't matter, you know, in that case you have to click here, the guided mode. Where is it? Yes, right over here. And then you have to, as you set the mode on basis of your commands given to the mission planner, given to your map, the position of the drone will change. I'll be showing that you know, in the live demonstration. Now there are some more configurations that you might want to change for the RTL mode. So I'm clicking on RTL, which is return to launch in other words. So the RTL altitude is the altitude at which the drone will be climbing at before returning to launch position, before initiating its navigation to the launch position, I should say. So by default it was 1500 centimeters, in other words 15 meters, and I've set it to 700 centimeters or 7 meters because I really don't need to fly the vehicle. I really didn't want to fly the vehicle at that much higher elevations because it will not give me that much clear visuals, or I won't be able to get clear visuals, you know, using my camera. So I've set the RTL altitude to 700 centimeters or 7 meters so that I can have a clear visual with my camera, so that I can show the demonstration later on. So here is the RTL speed. It's not been changed. The RTL accuracy, no, I've not, and this is the RTL loiter time. It is the time in milliseconds. In other words, it's 5 seconds. It is the time that the drone will be hovering above the launch position before initiating its final descent towards the launch point. So it's by default set to 5 seconds, and I've not changed it. So these are few of the settings that you may want to change in RTL. So I believe that I've covered everything. There is nothing left that I may need to cover. And if you have the geofence enabled, before taking off over here, you know, check the geofence distance. Make sure that the geofence distance is not very close, otherwise the vehicle will not take off perfectly. You know, there is high chances that the that it will crash. The propellers may get broken. So that's all about different types of flight modes and the geofence feature. The geofence is very useful, the geofence of inclusion exclusion. Mainly it allows you to fly within a limited region of interest and prevent any kind of collision or any unexpected collisions with any obstacles. So it's very useful, you know, the fence of inclusion. You don't have to worry, you don't have to bother about the obstacles, because you can fly in a safe zone of inclusion, or you can avoid the obstacles as the fence of exclusion. So the geofence is a wonderful feature, and in case of the altitude hold mode, as I cross the geofence, as I breach the geofence, the RTL mode will be initiated. But in case of the loiter mode, the RTL mode won't be initiated. Rather, the drone will not accept any commands from the radio transmitter. In case of the autonomous mode, you can't make any flight plans which is beyond the geofence of inclusion. For example, if I wanna go to plan and click on mission, even if I want, then I can't sorry, for now I have not written the geofence, so it will not work. So I'm gonna cancel it, the last waypoint. Yeah, so in case of the autonomous mode, you won't be able to set waypoints which are beyond the geofence, because in that case and that's why it will allow you to fly within the fence of inclusion. And in case of the guided mode, similarly, if you are you can't set any waypoints which is beyond the geofence of inclusion. Maybe I made one mistake. In case of the autonomous mode, you can set a waypoint beyond the geofence, but in that case the geofence breach will be triggered and the RTL mode will be initiated. But in case of the guided mode, you cannot command the drone to any waypoint which is beyond the fence of inclusion. So I believe that I've been able to make myself clear enough. Sorry for any sort of confusions. So that's all for now. I will be showing you the demonstration of all these flight modes as I've been talking this while, like the stabilize mode, the altitude hold mode, the loiter mode, the RTL, land, auto, guided mode with the geofence feature enabled in the next video. So that's all for now. Thanks for watching. Stay tuned for the next one. Bye for now.